Good evening, Gloucester Severn. A pleasure to be back to talk to you once again. So yes, exploring the solar system. In this case, I'm giving you parts 1 and part 2. So firstly, robots on Mars. I'll be saying a little bit about Martians and then talking about landers and rovers and asking what are they doing, what have they found, and then asking what comes next. So we Earthlings have had a fascination with Mars for quite some time. If you talk about Martians, then some people will think about War of the Worlds, whether it be the book, the radio, the film, or possibly even the musical. But if you talk to a youngster and ask him or her about The Martian, then more likely he'll think of the Matt Damon version of The Martian. But we ought to just take a second and remind ourselves how remarkable it is that we can get images like this. 1,000,000 years ago, we were swinging around in the trees. 100,000 years ago, some of us were still living in caves. But now we're capable of building machines, putting them on top of a rocket, sending them to another planet, and landing them. And then they send back pictures like this. A high-resolution panorama of the surface of Mars. It looks dry at the moment. We've got dried up riverbeds, dried up lakes, but there's plenty of evidence that water did flow on Mars. And if water did flow, is it possible that life got started there? Is it even possible that life is still there? But perhaps not on the surface, perhaps underground. So we need to explore more to find out about this particular planet. And that's what most of these rovers are doing. So I'm not going to cover every mission that's been to Mars. Here are some of the NASA missions. Back in the 1970s, a Viking lander, and then there have been rovers. 2004, there were a couple of rovers sent. And then in 2012, a bigger rover called Curiosity. And then the most recent 2020, a rover called Perseverance, or Percy to his friends. So yes, these are just the NASA ones. China have sent a lander and a rover, and there are plans for a European rover, which I'll tell you about a little later. I'm just going to make mention of these ones in red, because I haven't got time to cover all aspects of how we've explored Mars. So it started back in the 1970s when this lander, Viking, landed on Mars. No, we didn't send Carl Sagan at the same time. This is Carl Sagan standing next to a model of the Viking lander, just to give you a sense of scale. But in the 1970s, the landers sent back images like this, the first colour images from the surface of Mars. And I remember at the time being quite amazed. I was a teenager at the time and I thought, yes, it's great that we've sent men to the moon, but it's also fantastic that we've been able to get colour images back from the surface of another planet. How do we get rockets there? Well, the rockets are actually quite small, as indicated in the top left, compared to the Saturn V in the bottom right. An Atlas rocket can get a rover to Mars, but it's much smaller than the Saturn V that went to the moon, even though the moon is a lot closer. Well, it's actually not about distance, it's about mass. It's about how much you want to actually lift into orbit or send to another planet. A rover might only weigh a fraction of a ton, or maybe a ton plus. But the Saturn V had to lift over 100 tons into Earth orbit. So it's not distance, it's literally how much mass dictates how large the rocket needs to be to get you there. This is how Spirit and Opportunity, the two rovers back in 2004, arrived at Mars. When they arrived at Mars, they went through the atmosphere with a heat shield to slow them down, a manoeuvre called aerobraking, until they were slow enough to deploy parachutes. They're still supersonic at this point, so it's a supersonic parachute. And eventually the whole system slowed down enough that they could dispense with the heat shield, and then the rover itself is inside this little pyramid on the end of the tether. So the question is, how do you get that onto the ground safely? The rover might only weigh a few hundred kilograms, but they decided that the best solution, airbags. You don't have to land precisely, you slow down as much as you can, and then you drop it. Doesn't really matter from what height, it doesn't really matter if you're going a little bit sideways, it's not a precision drop. You deploy the airbags and then you just let it bounce. Okay, the rover has to be very securely packaged inside the airbags for sure, and the accelerators on board told Mission Control that it bounced 28 times before finally coming to rest. Once it's static, the airbags can be deflated, and then the little pyramid holding the rover unfolds. A very clever design that is effectively self-righting. So there's the rover inside. Once the pyramid has unfolded, the rover itself starts to unpack itself. The first thing that happens is the solar panels deploy. It's battery operated and it needs those solar panels to charge the batteries to give it the power it needs. So the solar panel unfolds, and then a mast holding a camera unfolds and raises the camera to a high position. There it goes. And in the background, that thing that looks like a table tennis bat, that's the antenna that allows it to communicate with any spacecraft in orbit and hence any spacecraft back to Earth. So the rover takes a quick look around, makes sure it is indeed the right way up, tells Mission Control I've arrived, does a little bit of diagnostics, and then Mission Control say, okay, go for it. Start moving. So the rover then unpacks itself, deploys all 6 wheels, there they go, and then it's about to leave the platform it's landed on, so it needs to do another check of where it is. So it looks around for any obstacles. Stereo cameras allow it to judge distance, and so it then trundles out onto the surface of Mars. These rovers, Spirit and Opportunity, were designed to last at least 3 months. In fact, Opportunity lasted 14 years, a testament to the engineering to produce rovers like this. So off it goes. It's got an awful big planet to explore. It's only got a finite distance that it can possibly cover. Part of the problem with the whole power systems, the idea of using solar power, Mars is a little bit further from the sun than Earth is, but still solar panels are a good idea. But Mars is a very dusty environment. So here's a selfie taken from the camera on top of the mast looking directly down, a montage showing you the solar panels. But after a little while, because of the Mars dust, the solar panels can get rather covered, and here you can hardly see the spacecraft, the rover, simply because it's covered in dust just like the soil behind it. And that will reduce the efficiency with which it can recharge its batteries. And this is rather important. Mars is similar to the Earth in the sense of being a little bit smaller, but it's got a similar tilt, 25 degrees rather than our 23.5, and it's got a similar day, a little over 24 hours, 24.5 hours. So it has a similar day-night cycle, and it has a similar season cycle of winter and summer because of the tilt. That means days can be substantially warmer than nights, and in the case of Mars, a day temperature might be of order 20 Celsius. If you're lucky, it'll be above freezing, maybe around there. But at night time, the temperature can plummet to -100 or lower, especially during the winter. And the rovers have to keep warm during the night. So during the day, they've got solar power, and the intention is that the solar power will charge the batteries, and the batteries at night will run heaters to keep the rovers warm. But the reason Opportunity eventually died after 14 years was not because it broke as such, but because there was a Martian dust storm. And if there's a dust storm, it can obscure the sun, and so on a Martian winter, it could not power its batteries because it couldn't see the sun. And so, after 14 years on the surface, the final transmission from Opportunity, 14 years after it landed and started roving, as the night was drawing in and it couldn't recharge its batteries, it knew it was going to freeze and it knew it was going to die. So the last transmission from Opportunity, battery low, getting dark. And that is the last we heard of that particular rover. For future missions, NASA decided, let's do it a little differently. Let's send heavier, more massive rovers, and rather than use solar panels, let's use thermoelectric generators so we don't rely on the solar panels. Perseverance and Curiosity, I'm going to be talking about Perseverance here, they had a similar entry into the atmosphere, but they landed a little bit differently. So let's follow an animation of how Perseverance got to the surface of Mars. Again, it comes into the atmosphere and it does an aerobraking maneuver. A heat shield slows it down as it comes into the atmosphere. There's Perseverance inside its shell, getting a little bit buffeted. As it comes through the atmosphere, the shell has a limited amount of steerage with those jets, and then again a parachute slows it down still further. But given that this rover weighs more than a ton, it can't use airbags. They have to find a different solution. So they jettison the heat shield and then drop an assembly which contains retro rockets, which slows the descent down. Downward pointing cameras tell it where it is. This has to be done autonomously because there's too much of a time delay between Earth and Mars. So it tries to seek out the predefined landing site and then goes into a hover maneuver. It can't go to the surface because the jets would kick up too much dust. So they hover and then winch Perseverance down on cables. Once it's down, the cables are guillotined and the sky crane flies away at a safe distance and crashes, leaving Perseverance on the surface. Notice no solar panels, but a large generator at the back end, a thermoelectric generator which provides all the power. And this long, slow pullback is a reminder that even if we have a lot of rovers on the surface of Mars, and Mars is smaller than the Earth, it's still a huge area to explore, which is why they were very careful in trying to put the rovers down where they would do the most good, where we would learn the most about the climate and the geology of Mars. So there's Perseverance, or Percy, and Ginny, the helicopter. There's Ingenuity, otherwise known as Ginny. So this is clearly a selfie. But how do you take a selfie? Well, you know, if you've got a phone, you just hold it up and click and you're done. But here, how do you get a selfie like that? Yes, there are cameras on the mast that we can see in the middle there, but there's also a camera on the robot arm. And the robot arm is used to take a whole series of images and then montage them all together. So it's not just a snapshot, it takes a lot longer than that. There's the camera on the robot arm, which is moved backwards and forwards. The lens is circled there in white. So it goes backwards and forwards, taking a whole load of images to finally produce the final montage. And this is actually two images with the camera pointing in different positions. You can see Percy there glancing over its shoulder like a nervous dad, making sure that the toddler is still where it should be. Where did the helicopter come from? Well, the helicopter came in on the belly of Perseverance. It was on the belly and then it was unpacked. And once it was down on the ground, Perseverance rolled away to leave the helicopter. And here's the helicopter with its flight. There's Ingenuity in the bottom there. And I don't know if the sound comes across very clearly, but as well as a little bit of wind noise, perhaps you can hear a humming. The hum is the sound of the rotor blades turning, so you're listening to a spacecraft on another planet. The idea of a helicopter is that it could scout further than the rover. The rover moves very slowly, a helicopter can move substantially faster and can basically fly over the next hill and tell the rover what's around the corner and basically plan out its route more accurately. It was also a test bed for the idea of sending a helicopter elsewhere. There are plans to send a helicopter to a moon of Saturn called Titan, which has got a very thick atmosphere, which means the helicopter can be quite heavy and carry a lot of scientific equipment. We're very interested to know what the atmosphere and the surface of Titan actually looks like. We've had a probe go there. I'll be telling you about that in a few minutes. But the idea of flying a helicopter means that we could cover much more ground. NASA are quite keen for publicity to get people on board with the idea of sending probes throughout the solar system and particularly to Mars. So they made boarding passes available. So I applied to NASA and said, can I have a boarding pass for Perseverance, Mars 2020, as it was called at the time. And NASA are quite happy to give away boarding passes because it costs them essentially nothing, but it invests a certain amount of interest amongst people who get their name basically put onto a tiny chip. It only costs a few milligrams as far as NASA is concerned, but people can have their names on a tiny piece of silicon put into a little plate, and that plate is at the back end of Perseverance. And that means that when Perseverance explores Mars, I'm going with it. I feel like it's part of me going with it. And if you get a few million people doing the same thing, it costs essentially nothing, but it's a great way of getting people involved and getting people interested in space exploration. And NASA are now doing this for all of their missions, including ones to the outer solar system. So why do we explore Mars? Well, primarily to study its geology and study its climate and ask the question, does life exist? And if it looks like we haven't found life, we can ask, well, did it exist at some point? Because we know water flowed on Mars and we know water is a very good way of starting life. Maybe it did start, maybe it's now extinct, but maybe it started and maybe it's still there under the surface. One other reason we might want to explore Mars now is to prepare for the possibility of human exploration in the future. So Perseverance is taking samples as it goes. It's collecting rock samples, it's collecting atmospheric samples, and it's leaving a trail of samples behind it and also taking a number of samples with it as it explores the Martian surface. It can do a certain amount of analysis itself, but it would be really useful if we could get these samples back to Earth because, of course, the analytic instruments we have back on Earth are more sophisticated than the ones we can possibly send in a small rover. So how might we get these samples back to Earth? There are plans between NASA and ESA to send a lander to join Perseverance. It'll be a lander, not a rover, but once it lands, Perseverance will go and meet it. And once it meets it, it will take samples from itself, from its own data store, and it will transfer them into the lander. You can see perhaps a few dozen samples will be transferred from Perseverance into the lander. Okay, that's fine, but then how do we get them back to Earth? Well, it's actually transferred them into a small rocket, and that rocket will then go into Martian orbit. There's Perseverance watching it go. It'll go back to Mars orbit. The samples will be taken from that canister into another spacecraft and then flown back to Earth. So that's a plan. And at the moment it is only a plan. They've decided to collect the samples, and NASA and ESA got together with this idea of a Mars sample return. But they've now decided, well, actually, that's quite an expensive way of doing it. And they're trying to figure out if there's a cheaper way. So that's one possibility that might happen in a few years, but ideally they're trying to figure out cheaper ways of doing it. What's next? Well, there are more rovers being planned. For instance, there is a European rover, an ESA rover. The European Space Agency is designing this one for launch, perhaps not 2028. I think it's probably delayed. It's more likely to be 2029 now. It's a relatively small rover compared to the ones that NASA has sent. So what makes this one different? Well, it's different because of that black box on the front of the rover. The rover is designed to explore different parts of the Martian surface, and then the black box is a drill which will allow us to go down something like 2 meters below the surface. If there is water below the surface, we're not too sure how deep it would be, but the hope is it's less than 2 meters down. If we can establish that water is definitely below the surface, as indicated by the existence of riverbeds and lakes, etc., then there's a chance that if life evolved, it might be down there. So in a few years' time, it's quite exciting to realise that Europeans will have a rover on Mars. And it's not only European, it's basically UK. Airbus UK are building this rover called the Rosalind Franklin. And there it is in Airbus UK being constructed. I hope somebody has actually told these guys that instead of 6 wheels, it appears to have 5, and a shopping bag has been added to the back end, but I'm sure they actually realise that. So it's on its way, it's being built. Hopefully it'll be ready before too long, and hopefully it'll be on the surface of Mars in only a few years. So if you want to know more about robots on Mars that have been there in decades gone by, or perhaps will be there in a few years' time, you can go to the web pages of these various space agencies to learn more. Thank you very much.